Today we're doing percentage yield from the Platinum textbook, page 173. The worked example, it says calculate the percentage yield of steam obtained if 136 grams of steam is produced from 20 grams hydrogen gas and an excess of oxygen gas. Notice in this example, they're telling us which one is in excess. The first thing you're going to have to do is write down a balanced chemical equation. They have not given this to you. It says calculate the steam. What is steam? That's H2O gas that's produced, so it's 2H2O. And it's produced from hydrogen, that's H2. So 2H2 plus O2 gives you 2H2O. This is the balanced chemical equation. Next, we're going to write down on top of each equation what they have given us. They said 136 grams of steam. So you write this on the top. 136 grams of steam and 20 grams of hydrogen. So that's 20 grams here. You have to start here, react, and end. So we can find the number of moles because they've given us the mass. We can easily find the molar mass and then the number of moles. So let's work out the molar mass of H2 first. So molar mass of H2, you'd look onto the periodic table for the mass of hydrogen, and that's 1. So it'll be 2 because there's 2 hydrogens times 1, and that gives you 2. And then we can work out the number of moles. Number of moles equals to mass over molar mass. The mass they've given us, which is 20, divided by the molar mass is 2. And this would give you 10 moles that we're starting with. So I'll write down 10 over here. Then we can easily find the number of moles of H2O gas. So we'll first find the molar mass of H2O, and that would be 2 times the mass of hydrogen, which is 1, plus the mass of oxygen is 16, and this gives us 18. Now that we have the molar mass, you can find the number of moles. Number of moles equals to mass over molar mass. The mass that they've given us, which is 136, divided by the molar mass, which is 18, and this gives us 7.56 moles. So I'll put down 7,56 moles as starting. Now we can easily find which is the limiting reactant. So we'll say 10 divided by 2 times the invisible 1, and this gives us 5. So I'll write down 5 moles that's being reacted. Then you'll work backwards to find out which one is limiting. So you'll say 5 divided by the 1 times 2, and this will give us 10. So we'll write down 10 moles that's reacting, and you'll minus it. 10 minus 10 is 0. So this is now the limiting reactant. Notice in the question, they've already told us which one is in excess. So you can already assume that this is excess. The question didn't ask us for the end product, so I'm just skipping through that real quick. From here, you can find out the maximum mass of H2O steam. Sorry, this is written in the wrong place. The 7.56 is the number of moles that's reacting. You can find the number of moles here by saying 10 divided by 2, which is 5, times 2, which is 10. So we're starting off with 10 over here. And I moved that down. The reacting was 7.56. Now we can easily find the mass of the H2O gas. First, we'll need to find the molar mass of H2O. So we have that as 18. We can easily find the mass of it. We'll say number of moles equals to mass over molar mass. And then you're going to manipulate this formula. You'll say mass will equal to number of moles times molar mass. And the number of moles that we have starting with is 10 times the molar mass, which is 18. And this will equal to 180 moles. Sorry, this is mass, so it's 180 grams. Now remember, this question is percentage yield. So you'll want to use the percentage yield formula, which I'm going to write in short form. Percentage yield will equal to the actual yield over the theoretical yield. So it's percentage yield over actual yield over theoretical yield times 100%. So we have the actual yield that they gave us to be 136. So you'd say 136 divided by the theoretical yield that we just calculated is to be 180. So divide by 180 times 100%, and then you can easily find the yield, which is 75.56%. So 75.56% is your answer.